Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 167. Page 167, and today is our lesson number 111. The problem that we're going to solve is 107. Please turn to page 167 and read the problem to yourself. We are told that we have 60% women. 60% women in a group. We are further told that 45% of these women are lawyers. The question simply is, what are the odds of picking a woman lawyer at random? What are the odds of picking a woman lawyer at random? The easiest and the simplest thing in a situation like this, when you're dealing with a percentage problem, is simply to make up a number. And a good number to make up in the context of percentage problem is 100. So we're going to pretend that we have 100 people. We have 100 people total. We're just going to make it up. We are told that 60% are women, which tells us that 60 of them are women. We are further told that 45%, percent means over 100, 45% of these 60 are lawyers. So this number represents women lawyers. Let's find out how many there are, shall we? If you divide top and bottom by 20, 60 becomes 3, 100 becomes 5. Well, that was simple enough. Divide top and bottom by 5. There are 9 5s and a 45. So it looks like we have 27 women lawyer. We have 27 women lawyer out of 100, and therefore the odds of picking a woman lawyer at random out of the group of 100 is 27%. Simple enough. The answer is C. The answer is C. Let's do next one, shall we? That's it. That was it. That was a pretty straightforward question. (108) it says each year the number went up by a quarter of the previous year. So whatever the number was, we are told that each year it has gone up by quarter of the previous number. We are also told that at the end of fourth year, we had a total of 6250. The question simply is, what was the beginning number? What did we start out with? Let's see what we can do. Alright, here's our solution. We are going to pretend that we started out with x. Let the beginning number be x. So here's our year 0, which is the beginning. In the year 0 it was x. At the end of first year, whatever it was, it increased by a quarter. So if it was x, we had a quarter more than that. And x by itself is same as saying 4 quarters. 4 quarter makes a whole. So 4 quarter makes a whole, and then it increased by a quarter. So we had 5 quarters. 5 quarter of x. The following year, it increased by a quarter more than this amount. A quarter more than this amount. A quarter more than this amount is again 5 quarter of the amount. So we had this amount at the end of first year. The second year, what we have is 5 quarter of the amount that we started out with at the end of the first year, which is the beginning of the second year. At the beginning of the second year, we started out with this amount, 5 quarter of x, and now this amount has increased by 5 quarters. So we have 5 quarters of 5 quarter, and so on and so forth. At the end of third year, we'll have 5 quarter cube times x. 5 quarter cube times x. And at the end of fourth year, we'll have 5 quarter raised to the 4th power times x. Because each year it increases by a quarter, which means each year, at the end of each year, it is 5 quarter of the starting amount. In the very beginning, at the year 0, it was x. The next year it becomes 5. For example, if it were 1, the following year it will become 5 quarter, because 1 is same as 4 quarters. The following year, it is this amount, 5 quarter, plus a quarter more of that amount. If you take 5 quarters common, if you take out 5 quarters common, here we are left with 1, and here we are left with 1 quarter, and that gives you another 5 quarter, which is why we get 5 quarters times 5 quarters, which is same as 5 quarters squared. So instead of writing the year 2 in this manner, we could have simply written it as 5 quarter squared times x. At the end of third year, what we have is 5 quarters cubed times x. And at the end of fourth year, we'll have 5 quarters to the raised to 4 times x. X is the amount that we started out with, which is what we want to figure out. At the end of nth year, it will simply be 5 quarters raised to n, whatever the n happens to be, times x. Now we know that at the end of fourth year, we are told that at the end of fourth year, the number that we actually have is 60 to 50, which means this quantity has to equal 60 to 50, and that's what it is. We have to solve for x. Therefore, I need the room, so I'm going to erase all of this now. So let the beginning amount be x, therefore, the amount that we have at the end of fourth year, which is 60 to 50, must equal this amount, 5/4 raised to the 4th power times x. Times x. Which means x equals to 60 to 50 times 4 raised to 4 over 5 raised to 4. We're almost there. 5 raised to 4 can further be written as 60 to 50 times 4 raised to 4 over 5 times 5 times 5 times 5. We're not going to do anything with 4 raised to 4, because there will be no point in it, because 4 does not divide into 5. So there's no point in messing with that. Just leave it alone. Let's start taking out 5s. Let's divide top and bottom by 5. How many 5 in a 6? 6 has 1 5. The remaining one goes and joins this guy, becomes 12. How many 5s in 12? 12 has 2 5s. Cross out 2 and write down 2. 12 has 2 5s. The remaining 2 again goes and joins this 5, becomes 25. How many 5s in a 25? 25 has 5 5s. Finally, how many 5s in a 0? 0 has no 5s. That takes care of the first 5. Let's divide top and bottom by 5 again. How many 5 in a 1? 1 has 0 5s. That one goes and joins the 2, becomes 12. How many 5s in a 12? 12 has 2 5s. The remaining 2 goes and joins this 5, becomes 25. How many 5s in a 25? 25 has 5 5s. How many 5s in a 0? A 0 has no 5s. That takes care of the second 5. Let's divide top and bottom by 5 again. How many 5s in a, this is 25 here. How many 5s in a 25? 25 has 5 5s. How many 5s in a 0? 0 has no 5s. That takes care of the third 5. Let's divide top and bottom by 5 one more time. And the 50 will become 10. 50 will become 10. So what essentially we have is 4 raised to 4 times 10. X equals 4 raised to 4 times 10. Let's find out what 4 raised to 4 is. 4 times 4 is 16. 16 times 4 is 64. That much you should know by heart. You should know this cube of the 4. There are some basic cubes that you should know by heart. I've talked about it many times. I'm going to do it one more time. I'm going to digress for a very quick second. You should know your squares 1 through 20, and you should know your cubes 1 through 10. I'm going to show you here which cubes I expect the one expects a person to know. There are some elementary concepts of arithmetic that you have to know by heart to save time. Do you understand? Here are some cubes that you should know. 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64. You should know that by heart. 5 times 5 times 5 is 125, 6 times 6 times 6 is 216, 7 times 7 times 7, you don't have to worry about it, 8 times 8, 9 times 9, and finally the 10 cube you should know by heart, which is 1000. Anyway, so this represents 4 cube. So let's take our 64, where should we do it? Let's do it right here. 64 times 4, 4 times 4 is 16, carry 1. 16, 6 4s are 24, plus 1 is 25. So it's 256 times 10 would be 256 and a 0. That's it, that's our answer, that's what x is. X equals 2560 and the answer is D. The answer is D. And that's all there is. I will see you tomorrow, okay? Bye now.